Okay, so this is my viscosity experiment. Over here, we have 250 milliliters of 5 separate fluids, carefully measured out into 5 glasses. In this, going in order here, we have honey, water, maple syrup, milk, and vegetable oil. Milk will be our fifth surprise liquid. Wanted to use ketchup, ran into errors. Milk works just fine though. And so we'll be starting off with the honey. We have a timer, a separate device, which we'll be using. And I will be dropping the ball right about the top of where the fluid reaches out to. I'll be starting as soon as I drop it. In 3, 2, 1. Okay. Now, in my hypothesis, I predicted that honey will be the most, because honey is the most viscous liquid. Well, I predicted that honey will be the most viscous liquid, and therefore the ball will take the longest time to reach to the bottom point compared to all the other fluids. And from the looks of it, it was right. It took a bit of time for the honey to slowly engulf the ball, but now it's steadying up, going slightly faster as we approach 40 seconds. And okay. 59.42. We have got it in 59.42 seconds for it to touch the very bottom here. We will be recording that for later. 59.42 seconds. So now to go on with our second ball, let's just use a random one. In 3, 2, 1. Okay, 0.4. 0.4 seconds, 40 milliseconds is what we got for the water. And next up will be maple syrup. We'll be starting this in 3, 2, 1. Okay, 0.43. We got 0.43 seconds. So pretty much just as much as the water. I predicted it would be a little more than that because maple syrup is known to be much more viscous than water, and it has a lot slower of a flow rate from my experience. But regardless, I guess it's different when you're dropping the ball. Next up is the milk, and we'll be dropping it from this angle as well. 3, 2. Okay. So 0.34 seconds for the milk. Lastly, we will be doing vegetable oil. 3, 2, 1. 0.14. So, okay. I think